Welcome to the Explainer. Today, we're going to talk about this invisible force that keeps our entire body running, blood pressure. Now, you hear about it all the time, right? It's one of the most vital signs of our health. But honestly, it's also one of the most misunderstood.
It's got this really notorious nickname for a simple and kind of terrifying reason. You usually can't feel when it's dangerously high. There are no warning signs, no symptoms, not until a lot of damage has already been done.
And the scale of this problem? It is absolutely staggering. Think about this. 1.3 billion adults worldwide are dealing with high blood pressure. That includes almost half of all adults just in the US. This isn't just some minor health issue. We're talking about a full-blown global health crisis.
Okay, so what is it really? Let's break it down. Imagine your whole circulatory system is this super sophisticated plumbing network. Blood pressure is basically the force inside those pipes. It's the pressure that makes sure all the good stuff, oxygen, nutrients, actually gets delivered to every single one of your trillions of cells.
So how does your body manage all this? To really get it, we've got to look at the incredible physics, physics, of fluid dynamics that's happening inside you right this second. It's this beautifully engineered hydraulic system. So what's the body's secret to controlling all this pressure? You might think, oh, it's got to be the heart, right? How hard it pumps. But actually, the real power, the real control, lies in the pipes themselves. To be specific, it's these tiny arteries called arterioles that do all the delicate fine-tuning work.
And this all comes down to a principle from a physics law called Poiseuille's law. Now, you don't need to remember the name, but you do need to remember this part, the fourth power. That's the key. It means that if you just cut the radius of a blood vessel in half, the resistance to the blood flowing through it doesn't just double. Oh no, it skyrockets by a factor of 16. It's this incredible exponential relationship.
This just goes to show you how ridiculously powerful the vessel's radius is compared to everything else, like how thick the blood is or how long the pipe is. A teeny tiny tweak in the size of that pipe has this massive effect. And that is exactly why the body focuses on either squeezing or relaxing those little arterioles to manage pressure from one moment to the next.
You know, your body also has this amazing built-in shock absorber. Your main artery, the aorta, and the other big ones are super elastic. So when your heart beats, bam! They expand to soak up that huge pressure surge. Then, between beats, they recoil and push the blood forward. It's called the Windkessel effect, and it's what turns that pulsating, jerky flow from the heart into a nice, steady, life-giving stream.
Okay, so we've got this incredible physical system, but how is it actually controlled? Well, the body uses this really sophisticated biological control panel, and it's got two main systems that work on totally different timelines.
First up, you've got something called the baroreceptor reflex. This is the fast one. It's a neurological system that works instantly for quick changes. You know when you stand up really fast and don't get dizzy? That's this system at work. Then you've got the other one, the renin-angiotensin-aldosterone system, or just RAS for short. This is the slow and steady one, a hormonal system that handles long-term stability.
So let's look at that long-term system, RAS. It's this absolutely brilliant hormonal chain reaction. It all kicks off in the kidneys. When they sense the pressure is a little low, they release an enzyme that starts the whole cascade. The final product, a hormone called angiotensin II, is a real powerhouse. It does two big things. First, it physically squeezes your blood vessels tighter. And second, and this is crucial, it tells your kidneys to hold on to salt and water. And what happens when you have more water in the system? You get more blood volume, and that raises the pressure everywhere.
So what happens when this elegant, finely tuned system starts to break down? What happens when that pressure stays chronically, dangerously high? Well, that constant force starts to wear everything down. The very pressure that sustains life turns into a destructive force.
And the damage isn't just in one place, it's systemic. It hardens your arteries, which makes your heart work way harder until it eventually starts to fail. It scars those delicate filters in your kidneys, making high blood pressure a leading cause of kidney failure. And really critically, it damages the brain. It can actually break down the protective blood-brain barrier, and we now know there's a powerful link between high blood pressure and the development of dementia.
Now, because of these really devastating consequences, there's been a huge shift in how doctors think about this. They're moving away from just looking at a single blood pressure number, a snapshot in time, and instead, they're trying to predict a person's total lifelong risk of heart and blood vessel disease.
And the tool for this is the new PREVENT equation. It's a major leap forward. It doesn't just predict heart attacks and strokes, it also predicts the risk for heart failure. And what's really important is that it's more precise and more equitable.
It does this by looking at things like kidney health, and get this, it replaces race as a factor with social factors, which we're learning are often a much more accurate driver of risk.
You know, for the vast majority of people, we're talking 90 to 95%, high blood pressure is what's called essential. That just means it's not caused by one single disease. It's a complex mix of your genetics, your age, your lifestyle, the whole shebang. Only a tiny fraction of cases are secondary, meaning they're caused by some other specific, identifiable condition.
But here's the good news. Our understanding of how to actually treat hypertension is entering this really exciting, revolutionary new era. We're moving way beyond just taking a pill every day.
Check this out. There's a new class of drugs called RNI therapeutics, and they are a total game changer. Instead of just blocking a protein in that RAS pathway we talked about earlier, a drug like zilebesiran goes right to the source. It goes to the liver and literally silences the gene that makes it key protein in the first place. And the result? A single injection can control your blood pressure for 6 months. 6!
Okay, so that's amazing. But what if I told you the most effective change might not be a pill or a shot at all, but a simple static exercise? Right, we all know running and cardio are great for you. But what's blowing researchers' minds is that recent studies show that isometric exercises, we're talking static holds, like a simple wall sit, can actually lower blood pressure even more effectively than running or even high-intensity interval training. The working theory is that when you hold that muscle contraction and then release it, you get this powerful surge of blood flow that basically tells your blood vessels, hey, it's time to relax.
So we're really entering a whole new era in this fight. On one hand, you have these genetic therapies that might only require 2 shots a year, and on the other, you have simple 10-minute exercises that could be even more powerful than running. Our toolkit for fighting this is more powerful than it has ever been, and it all leads to this one really hopeful question. Are we finally on the verge of defeating the silent killer for good?